Every Git tutorial shows commands. This one shows the data structures Git mutates on disk. Episode 3. Previously, we saw blobs, the objects Git uses to store file content. The SHA-1 work from before will help this land harder. But we ended on a problem. Blobs hold content, just bytes, no file name, no folder. So how does Git remember that 3b is hello.txt? 3 steps. 1. We make a commit and watch new object folders appear. 2. We open a tree, mapping file names to blobs. 3. We open a commit, the wrapper that turns trees into history. First, the commit. What does it actually do? Watch the folder change in real time. Recap. Blobs store content but not names. Next, commits, trees, and the folder changes that connect them. Git visualized to the metal. Episode 3, Part 2. Making a commit. Before we commit, let's check what is in .git/objects. 1 real folder. 3b. The blob from when we ran git add. That is all Git has stored so far. Now we commit. Git commit-m with a message. Git tells us it created the commit. The short hash on the left is the commit's name, 803c. Now look, 2 new folders, 68 and 80. Git just wrote new objects to disk. The blob was there before. Now there are 3 real folders, 3 objects. We know 3b is the blob from episode 2. But what are 68 and 80? 2 of them must be new object types. 2 unknowns. One command finds out. Git catfile-t. It asks Git what type an object is. Next segment. Recap. 1 commit created 2 new objects on disk. Next, we will identify them. Inside a tree, the second object type unpacked. Let's ask Git catfile-t on 68, and the answer, tree, a new object type. Now open the tree. Catfile-p, 1 line, mode 100644. Then the word blob, then a hash, then a file name. That's what a tree is. A list. 4 columns. The mode, the object type, the hash that points to the actual content, and the file name this content goes by. A pointer with a name attached. But 1 file is not interesting. Let's add 3 more files. Hello2, hello3, and an empty file. Then commit. Now look. 4 entries, 4 file names. But look at the hashes. Lines 2 and 3. Hello and hello2. They point to the same blob. 3b18 and so on. 2 file names, 1 blob. Remember from episode 2, same content always gets the same hash. The tree gives it 2 names. Deduplication with names attached. But what about 80, the third folder? Same command finds out. Next segment. Recap. A tree is a list of entries. Each entry points to a blob by hash with a file name attached. Previously blobs and trees. Now the commit. Same command. Catfile-t on 80. The answer. Commit. The third object type. Catfile-p. 4 lines. A tree reference. An author. A committer and a message. A small wrapper around a tree with a few stamps. 4 parts. The tree. The actual snapshot. The author who wrote the change. The committer who recorded it. Usually the same person. And the message. Why it exists. Now open the second commit. 5c2a. Same fields but 1 new line. Parent 803c. The second commit knows about the first. By hash. 2 commits. Connected by parent. The newer one points back. Git's history is a linked list of trees. Pointing backward. Blobs, trees, commits. We have all 3. Now the full picture. How they fit. Coming next. Recap. A commit wraps a tree with author, committer, and message. Parent links chain commits into history. 3 object types. Blob holds content. Tree holds file names. Commit holds history. Let's see how they connect. 1 commit points to a tree. The tree points to blobs. Commit is history. Tree is structure. Blobs are content. Now add a second commit. 5c2a. It points to its own tree, and it has a parent pointer back to the first commit. History forms. Now the full picture. 2 commits. 2 trees. Look at the middle blob. 3b18. Both trees point to it. Same content, stored once, referenced twice. This is Git. But real projects have folders. Nested directories. How does a tree handle sr/utils? Next episode, subtrees. Commits point to trees. Trees point to blobs. Shared content is stored once. That is Git's object graph. If this is the Git tutorial you wish you'd had, subscribe. 1 episode at a time, all the way to the metal.